Wow, that looks beautiful.
Yeah, I rethought about it. Just haven't had time to redo it. But basically, I've got a bunch of patents that's related to parallel path magnets. Basically, you can design a magnet circuit where you can cause the magnetic field to go one way or the other. And I don't have one out here to show you. But you can set it up such that the field is angular, and which is what's inside here. There's an angular magnetic field inside these with the north pointed inward, and then there's coils in here that, depending on which coil I charge, it will move. These magnets, they will attract one of the magnets and repel the other, and then you go the other way, it'll attract the magnet and repel the other. But I've got a different design that I came up with to do the same thing that will make these much shorter.
Yeah, that's amazing.
I haven't run this, and mainly I haven't run it because I came up with a new design. But a lot of it's 3D printed. This aluminum casting, I actually casted it myself, but I did that back in 2017, I think. For another project.
So is this an attempt towards just higher efficiency then, or?
Yeah, the electric field you put into this to make the field go back or forth, you put an impulse in it by about 4 milliseconds. So to go whatever direction we're. And the first one of these I made, I held it in my hand. It had a 9-volt battery. Initiated it with the 9-volt battery. 50 times in either direction. So I did a 9-volt battery, did 100 operation on it. But it was smaller one of these things. But I've never had any of these ever heat up as many times as I've pulsed them. And I even made one for kind of developed one for a cryo cooler oscillator. I had it oscillating about 72 hertz. And it's, for several minutes, and it wouldn't heat up at all.
Interesting. Okay. Yeah, one of the things that interests me about magnet motors is, like, I mean, there are so many claims out there, right? Like, people are saying, oh, over unity this, and, generates, you can close the loop potentially and all that kind of stuff, but there
are YouTube videos of magnet motors that do something similar to this, where they have a magnet on the piston, and then one of those, it's like a shop magnet where you attract, you turn a knob, it doesn't attract, and they had that at the top where it go back and forth, so it attract, not attract, so it attracts, not attract, attracts, not attract. This does something very similar to that. It's attracting and not attracting. But the forces that they're getting, those things are not going to be that very high. I think you get rid of high forces out here, but still, I don't know where to compete with a car engine.
Yeah.
They have to put a bunch of these together. The next design on this will be 4 of them, because what you can do is if you put springs on it. In fact, it doesn't work right unless you put springs on it. You put 2 sets of springs on it, and it will. You will take the energy out of one spring and put it into the next spring, and the energy from the next spring goes in there. So basically, you can design this where most of your force you're getting from the springs that you put in. So you're only putting a little bit of force from the magnetic field in it. And in fact, the field is only attracting probably only the last 10th or 2/10 of an inch of its movement to get in there and lock. So mostly it's the springs that are giving you your force.
Okay.
All you're doing mainly with the magnetic field is reversing the direction.
But for something like this, even if you're not able to hit any kind of OU or anything like that, you could still use this to make conventional electric motors more efficient, right?
Maybe, yes, I hope so, because technically you can drive it off of solar power. Like I said, if you just the way I designed these is that you can charge up a capacitor and you dump the capacitor into here. So while it's moving, you're charging your capacitor banks, moving. So you have like maybe a capacitor bank for each 3 of these. So you're charging 2 banks while one's being fired.
I'll go
So
in
you
there
can
and
charge up
the rest
capacitors
of it.
pretty fast.
Yeah, that's beautifully built. Beautifully built. Okay, well, thank you, Tony. Do you have anything else that you're working on, or is that pretty much it for today? Because we have the magnet motor, and then we have the.
Trying to build a lake. Well, after that, I'm doing trying to build a motor for a cryo system to oscillate a cryo pump. I mean, not a cryo pump, but a pulse tube.
Oh, okay, okay.
Trying to build a pump that uses the same technology. I've got about 11 patents, and most of those patents relate to this reversing the magnetic field in different devices. In fact,
Now,
this is a solenoid valve. It was originally a pneumatic valve that would move this solenoid into a closed position or open position. And I can do the same thing by just pulsing this these coils and causing this magnet in the center to move either this way or this way.
okay.
And these springs that it's moving, it's probably moving somewhere in the neighborhood of 80 pounds of compression on the springs. But the holding force on this one's about 300 pounds.
So would this be a little bit like Tom Bearden stuff?
No.
Okay, because he was talking about magnetic field switching also, right? Magnetic circuit switching, more or less.
There's a 1962 or 67 patent that describes this originally, and I took that and modified it. The 60s patents has a closed armature that's being moved back and forth. And this design, I'm having a magnet that's being moved. The armature is a magnet, not a piece of metal.
Okay.
So I redesigned what that 60s patent did. I wrote several patents, and I've got a couple patents on valves. I've got a patent for a vibration damper. And some of my patents I didn't pay the maintenance fees on, so you find them and you make them. Some of them I still claim, right. This one I still claim. But they do make electric solenoids this big nowadays, but the coils on them and the power requirements are.
Now, in addition to these, because you've got, again, the solenoid device, I mean, the magnet motor, the graphite device, you ran, I mean, you were the co-chair of the STAVE conference, and then you ran the SPECIF conference, and I was blown away by how many papers you guys did. I mean, that must have been exhausting. Did you pick up any ideas from that you wanted to build, or was it all too big?
Well, maybe, but at the time I didn't have the capabilities to do anything.
Yeah.
NASA would not let us, I worked with NASA at the time, so NASA, I did those conferences outside of NASA, and NASA, as far as I know, even today, NASA is not very favorable towards anything that doesn't blow smoke out the back.
Yeah.
Or at least blow propellant out the back.
Well, and what I remember from reading...
Solar's accepted. The only thing that's propellant is in solars.
From reading the papers, especially back in the STAFE days, people were proposing big ideas, and those are expensive, and, so.
Well, the difference between an engineering organization, which NASA is, and a science organization that the National Science Foundation is, of course, today money has changed, so this is the same, but, back 20, 30 years ago, a science experiment for the National Science Foundation was in 5 to 10s to maybe more millions of dollars and lasted over, maybe 5 to 10 years. In an engineering organization, you're given $10,000 and told to show results in 2 years and you don't get no more money.
Yeah.
So there's a big difference in both time and money between engineering and other. And you can't do this stuff in 2 years. This experiment here, if you had to do it even today, and had to pay the people, I'm not getting paid, and pay the people, this is a $500,000 experiment, easy. And most of that's in salaries. Most of this stuff we've we scrounged up. A lot of it Tim Pickens had, and Tim paid for the machining of the G10. He found a guy who had these tubes. This was the same diameter as that tube, except it's actually slants in the middle. But I think it's the same diameter. So if we need to raise it up, we can use that. It just won't be able to see through that as well. But we've, Tim Pickens found guys who found things, and we got another guy who knows people who build the Marchbanks and has them in town and different stuff. So.
Yeah, and that's amazing. And that's one of the reasons that I wanted to introduce you to some of the younger folks at the conference, because you have been in this area doing the work for like 30, 40 years now. And one of the things that I'm seeing is this area, as well as several others, it kind of comes and goes, right? It comes back into fashion. People get interested.
It's like a 30-year cycle on stuff.
Yeah.
That it takes 30 years for people to completely forget about it and they start it over. And my biggest problem with a lot of these things is that if it was really true and truly done, which this was not truly verified and truly done.
Yeah, and you're talking about the superconductor experiment there.
If it was truly done correctly 30 years ago, why spend your time doing it today? You need to investigate the experiment and see what they did and what improvements we can do that they didn't have back then. And then add those improvements. Just to try to repeat the experiment because you think it showed something that wasn't, conspiracy theory, is a waste of time.
Well,
unless you're adding something new to it.
There's a ramp up phase too, right? And I see this with pretty much every experiment out there, but like people don't just come in cold and build stuff. They have to learn it. They have to learn how it works. They have to learn the complexities of it.
Same with this. I agree with that. You may have to repeat the experiment so that you learn how to do things.
Yeah, and then when you have new people coming in every few years.
Don't start it unless you have improvements to add to it down the road. If you're just doing it to repeat the experiment, to me, it's a waste of time, unless the experiment was never done, never repeated correctly, which this was never repeated correctly. And so, I don't want to throw anything out there, but the Alzafon is one that I just don't see it going anywhere. I don't see any improvements. I don't see anybody discussing improvements to it. I don't see any people discussing how the scale up is of it. And so scaling up is a big issue. If you want, and actually, a DARPA guy told us once said we can get people who come in all the time who show us millinewtons of force. I mean, it's fairly easy to do systems that give you millinewtons of force. What they don't show us is scale up.
Well, but even millinewtons of force demonstrates that there's some kind of gap in physics, right?
Well, millinewtons of force puts you into a realm of what you're seeing might be just vibrations.
Okay, that could be experimental error.
Millinewtons of force are within the experimental errors of almost everything that's thrust related. So that's the reason your scale up's important. Okay, you showed us millinewtons of force. Now show us a newton of force. Then once you do that, show us 10 newtons of force. Show us how it's scaling up, and before we'll fund you, is what they're saying.
Yeah.
And that's all on you. That's not on them.
Well, and that's a challenge. I mean, I grew up reading Popular Science, Scientific American, Popular Mechanics, and you read articles about like superconductors or the other devices that you're working with, and the way that it's written, it makes it sound like it's this big organizational push by a massive government effort. But in reality, like the NASA experiments, that was a very small team, and you guys didn't have funding. And the impression that I got was NASA was kind of like, okay, you can work on it, but for God's sake, don't spend our money.
What I think something could happen is some guy with a lot of money should come out and say, I'll put up $10 or $100 million if you can show me the device that will levitate 10 centimeters off the ground, and it's not using any normal ways of doing it, a string or If you can show me a levitation of the device, no matter how much it weighs, 10 centimeters off the ground, that's done to an effect that's never been seen before, then I think you've shown at least the beginning of something.
Yeah. Although the issue there is then you have all the hoaxers come out of the closet.
That's why I say you got to prove that it's not being a hoax.
Yeah, because we've had, there's, in fact, the Debrief is running a story this week about, I'm not going to name which one, but they've got, a long time popular one that's soaking up a lot of time and energy from people trying to replicate it. And basically they're running what they believe is a debunking article on it. So.
When people come in to try to claim the $10 million, you get to explain what you did, how you do it, and you have to have a method to prove that you're not got it on a string. Like that Graviflyer, to me, I think it's a hoax. Because there's one video that he's in his living room, and I almost 100% positive I saw a string in that system. And then he does another video where he's out in the woods, and behind the experiment's a bunch of small little trees, and he's got this thing up on what looks like it's on a little slight pole, and he says it's levitating, but he accidentally touches it, and he goes like that, like it's on a little pole, and it's hard to see that pole because all those small little trees are behind.
So with the Graviflyer, I'm not gonna cast aspersions, but for me, it's a really interesting psychological test because Alexey Chekurkov, he started putting up these videos 5-6 years ago. He's got probably 10 or 14 people that are spending a lot of money on their own dime to try and recreate this.
None of them has seen anything.
Some of them have purchased devices from him, and there are always these caveats, right? So they'll purchase his Graviflyer, but he'll break it down and mail it to him in pieces. They've seen side effects. One of the things that Jared Yates has talked about is what he talks about, like a magnetic grinding that Alexey has described in detail. And he's like, you wouldn't know that unless you'd really spent a lot of time running this. But then at the same time, he hasn't seen the lift effects. So I go back and forth on it, but the psychological part of it is, okay, you have a lot of people that are excited. You have a lot of people that are trying to recreate it. And then I go 2 steps out and I look at those original videos. I'm like, wait a minute, this is a guy running around quite literally wearing a tinfoil hat in the woods. And I'm like, but you get in so deep, you start arguing the details instead of the big picture, right?
Yeah, I just don't believe that it's a real thing. I think it's a hoax. I could be wrong, but that's just my opinion of it. I built one, but after Charles in Florida got his and talked to him, some of the things I did were wrong. I didn't do it correctly, so I didn't really see anything. But what was interesting that I did see is the plate that has a magnet on that's rotating. And then I had an oscillating field on the 2 plates that are rotating, and then you have a field on the center one.
Okay.
That when I was running it once, I noticed that the lead from the rotating magnet plate to ground was putting out more current than what I was putting into it. It was almost like I was making a welder out of this thing. I've been needing to go back and try that, but I haven't done it.
Yeah, that brings up a couple other interesting points. So one of them is, you give people a challenge, even if that particular challenge can't be solved in that way, the creative problem solving that goes into it may lead to other innovations. And with the Graviflyer, it's out there as a goal, right? And even if people can't hit that itself, maybe they'll come up with breakthroughs or discover new effects. I think the other thing that's interesting is, in Alexey Chekurkov's defense, he claims very forthright, well, he claims it took him years to develop, but he says he came up with the concept by combining a bunch of things that he had read about.
Yeah, I noticed that his device incorporates a lot of stuff from a lot of different people.
So maybe some of those things have effects that even he wasn't aware of.
So in just my opinion, from watching the videos, I don't believe that it's a real effect. Yeah. And the fact that Charles hasn't been able to replicate from the equipment that he was sent, the original equipment that's in some of those videos Charles has, he can't get it to work.
Yeah. Well, and for my part, again, I went through all of his videos with a fine-tooth comb, and I felt from day one, I'm like, there's something about this that very much feels like a hoax, but at the same time, I haven't found any smoking gun proof that satisfies me. So I kind of go back and forth, and I think a lot of folks do. I think it's this back and forth on it where you're like, this doesn't look like it's real, but then at the same time, and I think that the challenge is we want to believe, right?
Yeah, I really don't like telling people they're wrong, because they might find something that no one else found. So I don't really like to criticize what people are doing out there. So usually during the APEC conferences, I keep my mouth shut. I wouldn't want to stand up and scream, but I just keep my mouth shut because somebody might find something. And we don't know what for sure.
Well, but then the other thing, and this, like, I find myself saying this over and over again, especially this year, is you go online and there's so much talk and you're doing the work, right? And there are a few other folks who are doing the work. And that's where it seems like it's coming back to right now is, we've learned a lot from the past. I mean, I can drag my camera around and document all sorts of stuff, but at some point the rubber has to meet the road, and that's what you're doing.
You have to do experiments, and 99% of the experiments will not show anything. But there's always that 1% chance that you will. So.
Yeah. Well, Tony, thank you yet again, sir.